Welcome to the EBS workshop. I'm Sudhakar Mungamudi, your host. Let me introduce my team. I'm joined by Nitin UCBS, who is an enterprise solutions architect, AJ Park, who is a senior product manager at EBS. And then joining from London is my colleague and solution architect, Basiruddin Sheikh. Thanks for your time this morning or evening, depending on where you are. So today we will talk about automating Amazon EBS snapshots for data migration and disaster recovery. I am based out of Palo Alto, California. So this is part of the AWS Storage Workshop, virtual workshop series. And I hope you had a great 2 sessions, best practices for transfer family services and migrating from on-premises file services to AWS hybrid cloud earlier this week. So this is the 3rd session, and next week we have 3 more amazing sessions, and we'll talk about more at the end of this session. So let me start with a promise for you. So some of you are already experts in Amazon EBS, and some of you are getting started. And some of you are automating the provisioning and management of EBS and EBS services. So this workshop is structured to cover for all of you and take away specific key items from this presentation today. So what are the learning objectives? I will cover some of the EBS basics and what's new in Amazon EBS. And after that, I will talk about introduction to the direct APIs and transition it over to my colleague, AJ Park. He will go deep dive into direct APIs. This is where it gets really technical. So please follow along. Some of the advanced topics of EBS direct APIs will be covered by AJ in this session. And then Nitin has created an elegant demo on demonstrating the EBS API usage for snapshots automation from on-premises or anywhere for a block workload. And then I'll take over and talk about snapshots management and Fast Snapshot Restore feature. This is a very interesting feature that some of you are already using. Thank you so much. And then we have a lab at the end. I scheduled the lab at the end for about 15 to 20 minutes so that you all have a chance to follow along the entire workshop on the training content as well as the demo content, and then move to hands-on workshop. The DLM workshop is hands-on, and we'll talk more about the lab instructions in the next slide. So here, the key is bullet number 4. I have uploaded a lab instructions document, and there is a short URL for Bitly for you. Please make sure that you go to that short URL and able to download the document. So this is externally available from wherever you are for the access. We will go through the lab instructions when we get to the lab section. That is the 3rd segment of today's workshop. Okay, let's see the agenda today. As I discussed, I will cover EBS overview and what's new in Amazon EBS, all the latest offerings that the Amazon EBS service teams have been innovating on your behalf. And some of you are already using those features, and some of you might have missed what's new in EBS. So let's do an overall cover of what exactly has been launched in the 6 months to 12 months prior. And we'll talk about the direct APIs. This is the section 2 or segment 2 of the workshop, direct APIs and the demo part. And then I'll take over and cover the snapshots segment along with the data lifecycle manager. Let's start with Amazon EBS overview. So in Amazon EBS is the overall block portfolio of AWS services. So as you already know, AWS block portfolio also has instance storage. This is specific to EC2 instances. So some of the instances I have listed here. So they have HDD-based, hard disk drive-based local storage for instance store, or NVMe SSD-based local storage for the EC2 instances. So instance store is very critical for some of your workloads who are complementing with your Amazon EBS disks, which we will cover soon. So the instance store lifecycle is tied to the EC2 instance, which some of you already know that if you stop and start an EC2 instance, the data does not persist that was on the EC2 instance store. Moving on to the key topic of today, EBS volumes. Amazon EBS volumes come in different flavors or volume types, as we call it. General purpose SSD volume, provisioned IOPS volumes, IO1 and IO2, as well as the HDD hard disk drive based volumes, ST1 for throughput oriented workloads, SC1 for cold infrequently accessed data or workload, and then the magnetic standard volume. This is the older generation volume which we still offer for your workloads. Snapshots, as you know, are incremental point-in-time copies of EBS volumes. Think of Amazon EBS Snapshots as a combination of a snapshot of that particular instance of the EBS volume and copied it over to S3 for S3 availability and durability reasons. And you can restore from the Amazon EBS Snapshot to any availability zone within that region, as well as copy it over to other regions or other accounts based on your own policies. So we will cover more about EBS snapshots in the third segment, as I explained before. And coming back to the data services, so you're already familiar with elastic volume features, like for example, how do you change the volume type from GP2 SSD volume to provisioned IOPS IO1 or IO2 SSD backed volume, or change the provisioned IOPS from say X number of IOPS to Y number of IOPS based on your workload requirements. This is done transparently without any impact to your workload or running application. Data Lifecycle Manager is how do you manage, create, delete, and lifecycle all of the snapshots. We have bundled in a service called Data Lifecycle Manager, and we will go deeper into that aspect in the third segment as well. Direct APIs, as I said before, think of this as previously you were managing snapshots by recovering into a volume and then doing some post-processing of what has changed between snapshot A and B. So all that we have enabled after listening to the feedback from customers all over, we have enabled a API access such that you can make a call to the snapshots and get information from that. And this is useful for backup partners and most of the customers who are able to automate on top of our APIs. So here, Amazon EBS volumes, let's go back into the EBS volumes. So this one, EBS volumes are attached to the EC2 instance, as you know. Many volumes can attach to an EC2 instance, and EBS volumes persist independent of the EC2 instance lifecycle. So let me touch upon that briefly. As I discussed before, the EC2 instance store lifecycle is synchronous with the lifecycle of the EC2 instance. When you start and stop, instance store data does not persist. Whereas EBS volume, even if you move from one instance to another instance, you can attach and detach, and it's independent of the EC2 instance lifecycle. Let's see some of the use cases, how our customers are using. And I have also customer examples in the next few slides coming up. Most of the EBS use cases fall in these broad categories, and some of you are using it for some other workloads that I have not listed here. Thank you very much in trying to innovate on top of the services that we deliver to you. So enterprise applications come to mind first, SAPs, Oracles of the world, both RDBMS databases, NoSQL databases, and big data analytics like Hadoop workloads, Kafka, Splunk. One of the customer example I will show you is how they are implementing data tiering based on various EBS volume types. And last but not the least is building self-managed file systems on top of EBS volumes for your specific workload requirements. Even though there are managed file services available for you for your workloads, some of you prefer, for various reasons, to create a self-managed file system on top of EBS volumes. So that's how our customers leverage the EBS volumes. This is a low latency and gives predictable performance in IOPS and throughput. And we have recently launched a new volume type called Provisioned IOPS IO2 with higher durability of 5 nines. Rest of the EBS volumes durability is 3 nines with a 5 9 availability across the board for all volume types. So we have seen the overview of EBS in the previous section. And then we talked about what are some of the broad workloads. So let us now see how a few typical customers at scale are using EBS. And if one of you is part of this customer, so thank you so much for being a referenceable customer. And because of you, we are innovating on your behalf. So let's take one example, Equifax. It's one of the largest consumer credit reporting agencies in USA and worldwide. So what Equifax has done is they have migrated hundreds of terabytes of on-premises data set to EBS. There are many methods available for you as a customer to choose how to migrate your on-premises data. Equifax has chosen the Cloud Endure migration path, which is another AWS service. And today we'll also cover native EBS service, which is Direct APIs, which we just recently launched a few months ago for using Write APIs. So they use about 300 plus EBS volumes of GP2 SSD type as well as ST1 HDD throughput based. So what is the business benefit they have seen migrating from on-premises to AWS is at the end of the month when they are running the report, they see great productivity and efficiency in running their operations. Let's go to the second example in the similar business space, but the workload is slightly different. Experian is another leading credit bureau. And again, thanks to Experian folks who are on the call. And if Mohit, you're listening, we are good friends. I know you from our previous work environment. Thanks again for this being a reference customer. What we have here, the Experian uses GP2 SSD-based volumes for their largest workload servicing their customers. And in addition to that, they have utilized the Fast Snapshot Restore for lots of volumes to quickly restore the data for testing and dev purposes or for disaster recovery purposes. So this has their time to market and agility factor increased by multiple times, and the productivity has increased a lot. So this is the utilization of SSD volumes in combination with the Fast Snapshot Restore or FSR feature. And I have provided links at the bottom for each of these case studies. So if you follow that link along, you will see more details and see what you can take away to implement your own environments. Or if you want, you can have, hey, we can help you implement some of these best practices that our largest customers are leveraging today. The third example I'm showing here and the final example, there are hundreds of examples. At the end of the slide, I have given you where you can go and see how about tens of customers or hundreds of customers case studies are deployed on AWS web pages. So here you can see Zendesk has about a tiering strategy. They use the GP2 volume for hot data, then use HDD volume for colder data set, and the least infrequently accessed data, they ship it to SC1 volume. This tiering strategy is built on top of the ELK or Elasticsearch, Logstash, and Kibana application workload. So what they do is because of the native tiering that is built into the ELK stack, they can reduce their TCO by moving the data, warmer data and colder data into the lower tiers of EBS volume types without any impact to the performance or their query times. All right, for some of you who are just joining, we just, on this workshop session for EBS, we covered what's new in Amazon, what's an overview of Amazon EBS, and we talked about a few customer examples. So what we are going to do now is see what's new that has been launched in the past 6 months to 12 months. And some of you are already familiar with these recent launches. I'll provide additional data points on the latest EBS service launches. Let's start with the EC2 instance. So in December of 2019, we increased the EBS Optimized Bandwidth. If you're not familiar with what is EBS Optimized Bandwidth, it is a dedicated bandwidth for EC2 instances to access the EBS storage. This is independent of the VPC networking bandwidth that you provision to your EC2 instance. So we have increased in December 2019 by about a factor of 36%. So imagine in your data center, you're running thousands of servers for your applications attached to a SAN fabric. So just take that example. So think of upgrading those SAN attached servers with a new HBAs. So this we have done without impacting your workloads across the board and provided this additional feature baked into the existing EC2 price point. So if you have deployed some of these servers that had gotten a boost of this from 14 gigabits per second to 19 gigabits per second, before December 2019, you need to stop and start to gain the additional performance enhancements. So how do we know that which EC2 instance has what kind of bandwidth? Some of the customers who have automated these workflows into the environment, they ask, hey, I cannot go to a static web page and look at it and say, okay, I run in C5 4x large or C5 24x large. So what is the baseline bandwidth, or what is my maximum performance at that point where I'm automating into my workflows? So as you know, everything you access in EBS, you can access through APIs and CLIs. So here I have provided you an example CLI that you can run on any type of instance, and I have color coded, so maximum bandwidth and baseline bandwidth, maximum IOPS. So this is a real-time information you get from the EC2 instance type for in your region, and then you can put this output into your automation workflows and design the overall solution based on the available performance from EC2 as well as EBS. So this is a describe instances API call. For EBS volume types, it is a describe volume API call. So combining these two, you know what your EBS volume can deliver, and you know what your EC2 instance can deliver with respect to performance. I see there are some questions being asked in the chat room, and my team members are answering those. So after this section, we will pause and take any live questions as well. But let me continue forward with three more slides, and we will take a pause for questions. So EBS portfolio recent changes on volume types. So as I mentioned before, we launched provisioned IOPS or IO2 volume. What is IO2 volume and how does it differ from previous IO1 volume type? So there are two enhancements to this with respect to IO1 volume. One is the IOPS density. So you can now provision up to 500 IOPS per gigabyte of provision storage. And then the durability of the volume changed by 100x from 3 nines to 5 nines. So this has become one of the very popular offerings in the recent past, and most of the customers are leveraging it for their workloads. Multi-attach, some of you are using multi-attach on top of a clustered solution, clustered file system solution. This is for IO1. Previously, EBS volume can only be attached to a single EC2 instance, and you can attach multiple volumes to an EC2 instance based on the attachments that EC2 instance can take. But with the launch of multi-attach feature last year, provisioned IOPS volume, you can attach it to up to 16 EC2 instances and share the capacity, the same data set and the capacity and performance across up to 16 EC2 nodes, Nitro EC2 instances. And we have added the encryption by default from your region, say single click, or you can have a CLI or an API changes to make encryption by default, and encrypted volumes you can create from unencrypted snapshots and AMIs. An AWS backup service integrates with EBS to protect your data. In addition to EBS Snapshots and EBS Data Lifecycle Manager DLM, you can also use AWS backup if you have that specific workflow in your organization. Coming back to snapshots, so snapshots support for point in time and crash consistent across multiple EBS volumes attached to a single EC2 instance. We'll talk more about that in later slides. And you can share snapshots across regions, across accounts with default AWS KMS keys or customer managed custom CMKs, as we call it. And then most importantly, the Data Lifecycle Manager, which is one of the key topics for this session. You will know how to automate some of the snapshot based on policies. Data services, we will dive deep into FSR or Fast Snapshot Restore that eliminates pre-warming requirements, or some of you cannot wait for the lazy loading of the data bytes from S3 into EBS volume, run your own manual scripts. So all this is eliminated for you on behalf of launching FSR feature service, such that EBS service provides you all the required infrastructure in the backend, and then your EBS volume will be fully performant instantaneously when you create it after it is FSR enabled. And then FSR limits have been increased because you have asked from 5 to 50. It says that you have various business critical workloads you can include in the FSR enablement. And we have gave flexible backup policies for DLM or Data Lifecycle Manager to support variable policies. Copy it from one region to another region with different policy sets of retentions. And direct API access, which is another major segment of today's workshop. So let's summarize here and pause for a bit. We covered EBS overview, and we talked about what's new in Amazon EBS with respect to EC2 instances, as well as EBS volume types and some of the data services. And for some of you joining now, we have a lab scheduled in this third segment, which is in bullet number 6 here, which is about 15 minutes, so which requires hands-on interaction on AWS Management Console. And I'll show you the lab instructions when we get there. So I'll pause here, ask if there are any questions, AJ or Nitin, we can answer live. We will take 2 questions before moving on.
Thank you, Sudhakar. Is there a link to the presentation that our viewers can download?
This will be shared on AWS channel on YouTube, and we'll make sure there will be a presentation link in that AWS channel as well. Thank you. Any other question?
No other questions, Sudhakar.
All right, let's move along. So here, this is the second segment. We'll be talking about direct APIs and what are the latest features that we have added, read and write APIs. So AJ Park, who is the product manager responsible for EBS direct APIs, is on the call today, and he will continue with the rest of the slides for the next 5 to 10 minutes. AJ, over to you. I will pause my video for now.
Thank you, Sudhakar. Hello, everyone. I'm AJ, a product manager for EBS, and today I'll talk about EBS Direct API. We launched EBS Direct API in December 2019, and there are 2 types of Direct API. There are Direct API to read and the Direct API to write. Let's take a look at EBS Direct API for read. Next slide, please. So EBS Direct API for read will allow you to list the blocks in a snapshot, in an EBS snapshot. It will allow you to read blocks from a snapshot. And given two snapshots, the EBS Direct API for read will allow you to determine which blocks have changed between those snapshots and read the changed blocks. And with this, you get 70% faster backups, which means you can perform more backups in a day, which gives you more recovery points. And it reduces your costs. Now let's take an example and see how this works. Next slide, please. Next slide. And one more. Thank you. So before EBS Direct API, if you had to compare the blocks between two snapshots, let's say snapshot A and snapshot B, and if you had to read the change blocks, what you would do is you would create two volumes, volume A from snapshot A, volume B from snapshot B, and you would attach those volumes to an EC2 instance, and then you would read each volume block by block, compare the data block by block to determine which blocks have changed, and then you would read the change blocks from the volume. And as you can imagine, this was a very resource-intensive and expensive process, because even if few blocks had changed, you would still have to scan the whole volume and compare block by block to determine what has changed before you can actually read the change blocks from the volume. Next slide, please. Thank you. With the EBS Direct API, let's look at the same scenario. You have two snapshots, snapshot A and snapshot B. Now you can directly determine which blocks have changed between the two snapshots, and you can directly read the change blocks from the snapshots. You no longer need EBS volumes. You no longer have to scan the whole data to figure out what has changed. And if you're using a serverless architecture, you no longer need EC2 instances. You can use Lambda functions to directly invoke your EBS Direct API, determine which blocks have changed, and read the change blocks. So this significantly reduces your backup times up to 70%, gives you more recovery points because you can take more backups because each backup is much faster, and it reduces your costs. Now let's take a look at EBS Direct API for write. Next slide, please. EBS Direct API for write allows you to create a snapshot directly from any data, from any place. Your data could be on-premises, or it could be in AWS cloud storage. If you have the data and you have access to the AWS EBS endpoint, you can create a snapshot from it. And because of this, your backups can directly be stored as snapshots, which give you faster recovery times, a simplified DR recovery workflow, so you don't need a custom DR solution, and it reduces your costs. Let's take an example and see how this works. Next slide, please. Thank you. So let's say we didn't have EBS Direct API. Before EBS Direct API, at recovery time, you would have to read your data from your backup. It could be in S3, could be in any other place. And you would have to copy that data from your backup to an EBS volume. And depending on the size of your backup, that copy could take 6 hours, it could take 10 hours. And only after all the copy was complete, all the data was moved, could the application start accessing the data. Now let's look at the workflow with EBS Direct API for write. With EBS Direct API for write, your backups can be stored in native snapshot format. So at recovery time, you just need to create an EBS volume from the snapshot and have your application start accessing that EBS volume right away. And if you have Fast Snapshot Restore enabled for that snapshot, you can get full recovery performance. So EBS Direct API for write allows you to get faster recoveries, it simplifies the DR workflow, and it saves costs because you use less AWS resources for a less amount of time, reducing your AWS usage cost. Thank you. Over to you,
Thanks.
Sudhakar.
That's very helpful. Now you can go offline on the video. So what AJ has just explained, we will see an elegant demo that Nitin has set up for us.
Thank you, Sudhakar. Hello, everyone. My name is Nitin, and I am an enterprise solution architect with AWS. As covered in previous slides, using EBS Direct APIs, you can now create new snapshots from your on-premises volume or create incremental snapshots. Once a snapshot is created, it has all the benefits of snapshots created from Amazon Elastic Block Store or EBS. For example, you can copy them, share them between different AWS accounts, keep them available for a Fast Snapshot Restore, or create EBS volumes from them. We will cover this use case during our demo today. Let me walk you through the architecture, which we will follow during our demo today. On the left side, we can see a sample on-premises application whose volume data will be created as EBS Snapshot using direct APIs into AWS. We will be using following EBS Direct APIs over a secured connection. First, we will call the Start Snapshot API, which will be used to create a new snapshot. Then put snapshot block, which will be for each block of data. And finally, we'll call Complete Snapshot API, which is after you send all the blocks. We will create snapshots from on-premises volumes without the need to spin up Amazon EC2 instances and attaching EBS volumes to it. This allows us to lower the cost of creation and management of a disaster recovery copy in the cloud. Once the snapshot is created, we will create an EC2 instance in an availability zone, then create an EBS volume from the EBS snapshot that we created from on-premises disk using EBS Direct API, and finally attach the new restored volume to our instance. Now let me show you the demo on the AWS console. I will be logging in to AWS account using my AWS username and password. And then I will navigate to the EC2 console. For the purpose of the demo, I have created two EC2 instances. One, as you can see, the source instance, which will be mimicking the on-premises application. And the other one is the destination EC2 instance on which we will restore the volume created from the EBS snapshot. The application that we will be using today is based on Apache Solr, which is an open source enterprise search platform built on Apache Lucene. So what I've done is, as a part of the application, is created a simple API on which I've indexed AWS database offerings. So as you can see, I'm able to query the API through a query term database, and it returns the information around all of the AWS database offerings. I can further query this with any other term, for example, commerce, and see what are the database that can be offered as a part of commerce offering. So what we'll do now is we'll go ahead and log in to the source machine. For this, I will go ahead and SSH into the console. So what I'm doing now is I'm SSH into the source machine. From here, I'll inspect what are the different block devices which are attached to the source machine. So as you can see, I have one of the source disk, which is over here as XVDF, which is having my my source application, which I will be using to create a snapshot of. For test purpose, we have created a Java application which will use EBS Direct APIs and create a snapshot of our source disk, which is XVDF in this case. So let me run the command. So as you can see, the first call will be to start snapshot to create a new snapshot. When the snapshot is incremental, you can pass the ID of the parent snapshot. You can also pass additional tags to apply to the snapshot or encrypt these snapshots and manage the key. Please check our technical documentation to know more. So in this case, I'm going to start the test. So now what it is asking is, or verifying the source disk. So in this case, I've already passed my source disk path with this /dev/xvdf. So I'll continue. So as you can see that for each block of data, put snapshot block API is called. This API takes 6 parameters, which includes the snapshot ID that we got previously, and also the checksum and the checksum algorithm, which you can see it on the screen. The checksum that you provide is validated against a checksum generated by Amazon EBS to validate the integrity of the data. After you send all the blocks, you call complete snapshot API with change blocks count parameters having the number of blocks you sent. So now it is completing the snapshot. And the snapshot with the snapshot ID is back to us. So now we will go back to our AWS console and look at the snapshot created. So I'll go back to the EC2 console, and from the left navigation, I'll click on snapshots under EBS. As you can see, our snapshot has been created successfully. Now what we'll do is we'll create a volume out of this snapshot and attach it to our destination EC2 instance. Before we do that, let's go and inspect our destination EC2 instance. So as you can see, in the destination EC2 instance, under storage, we have only the root volume attached. So now we'll go back to our snapshot, look into the snapshot we just created. We will right click and say create volume. On the create volume screen, for the purpose of the demo, we'll leave the defaults as it is, which is default in my account as of now. We will go ahead and create the volume. So once the volume is created, we'll navigate back to volumes under Elastic Block Store. So as you can see that our new volume is ready to be mounted. So I'll go ahead and right click on this volume and attach this volume to the EC2 instance of destination. And then after this, we'll log in and mount the volume and check all the data. So I'll go ahead and right click and click attach volume. From the instance, I'll select the destination EC2 instance in our demo, leave the defaults and click on attach. Now we'll go back to our instance and check the status of the volume. We'll click on destination EC2 instance. And validate if the new volume has been attached or not. Now we'll go to the destination EC2 instance and log in. So I'll click on the destination EC2 instance, click on action, connect, and from my SSH client, I'll copy the SSH command. I'll go back to my console, exit out of my source EC2 instance, and log into the new one. Once I'm logged in, I'll go and inspect my block storage devices. So as you can see, currently the device is attached but not mounted. So we will go ahead and mount the device. For that, we will use the mount command and verify that the device name is correct. So in this case, it is /dev/xvdf, and then we are mounting it to /data. After this, we'll verify once more if our device has been mounted. Looks like it is. Now we will navigate to our mount location. And as you can see, all of my files and my installation of Solar is intact. Now we will go ahead and restart the Solar service to make sure that index data is not lost. So I'll go ahead and restart. And I'll be using the default configuration and default ports on my destination machine. In this case, port 8983. So now it looks like Solar is up and running. So we will go back and verify if we are able to access our indexed data. We'll go back to the browser. And yes, we are able to see that all of the data that we took as a snapshot using EBS Direct APIs and created the volume out of it is intact. Let's do a little bit of more searching. If I type commerce, I'll get back the result related to that search term. And if I select Amazon, I will be able to see the rest of the data. So as you have seen today, that by using EBS Direct APIs, we were able to create snapshot from our on-premises volumes into AWS. And then from there, we were able to create volume and attach it to our EC2 instance and access our data. All of the links to the API documentation will be shared as a part of the workshop resources. Now I would like to transition to Sudhakar to continue with the rest of the workshop, and thank you for your time today.
Thanks, Nitin. That was very helpful. All right, so let's talk briefly about the demo, what you have just seen. So far, you have seen the overview of EBS, customer examples, direct APIs, what they are, and how they can help you read and write snapshots. Especially the demo was built around writing snapshots from your on-premises storage to AWS directly without the requirement for EC2 instance. So that's a huge reduction in your costs overhead, right? So that's a key point I wanted to make. So the overall theme of this workshop, if you see it, one is migration of data from on-premises to AWS that you have just seen. The second segment is once your data is block data is in AWS, how are you going to protect it, how automate it for disaster recovery purposes, policy-based, and everything using APIs, CLIs, or CloudFormation templates that you'll be using. So the next section, we'll be talking about snapshots, DLM, and this will be the hands-on session. So far, you have been following along with the workshop material and content. Thank you so much. For the next part will be the hands-on exercise, about 15 to 20 minutes of the hands-on DLM lab. So at this stage, Nitin, you want to add a word or two on the demo or any questions we have regarding direct APIs in the chat room that we can answer now?
The question is a snapshot consistent if the application is running?
Good question. So as I have explained before, EBS snapshots are crash consistent. And for Microsoft Windows workload, you can enable volume shadow copy snapshots, VSS, that are application consistent. For your Linux workloads, you need to make sure your file system and above consistency is taken care of to have the application level consistency. So most of the customers, how they do it is they have this momentary pause and take the snapshot instantaneously and then unfreeze the application or unpause the application. So the whole process may take less than a couple seconds. Once you take a snapshot, the snapshot ID is given back to you, and that is your recovery point. However long it might take to copy the data from EBS service to S3, your recovery point is when the instant your snapshot is obtained to you. Any other question, AJ? All right. Let's continue with the rest of the workshop and talk about more about snapshots and DLM and continue with the DLM hands-on lab. So we are almost quarter to the hour. So I will say next 15 to 20 minutes will be the last segment, and then we can regroup for question and answers and wrap up. So what are EBS snapshots? As I just explained, they are point-in-time copies of an EBS volume. Let me repeat the point-in-time nature of that. Whenever you issue a snapshot, create snapshot API call and take a snapshot from your AWS management console, you will get a snapshot ID, and that is your recovery point. And you can have multiple snapshots at different periods, and the incrementality kicks in because only the changed blocks are copied into S3 to reduce your total snapshot costs. Incrementality doesn't mean that you cannot delete previous snapshot if you no longer need. So at any given recovery point contains all the information to restore a volume to that point. This is very critical information that most of our customers asks and implement such that they have a snapshot hygiene, deleting the previous snapshot that they no longer need. Imagine as a recovery point that you no longer need from last week ago, 2 weeks ago. So what if you delete them? That's a common question I get all the time. So even if you delete the older snapshots, EBS service takes care of copying the bits and bytes required to restore the volume to the recovery point you desire. And these are stored in S3, as you know, and crash consistency. We answered in the previous question for application consistency for Windows, Microsoft workloads, we can use the systems manager based VSS snapshot, volume shadow copy snapshots, or for Linux workloads, you can have a automation on top of EBS snapshot service to freeze your application momentarily and take a snapshot and unfreeze or unpause. Previously, snapshots, if you're restoring a snapshot, you had to pre-warm them. So what we have done to eliminate the wait time for pre-warming to restore the EBS volume to fully performant scenario, we have launched a feature called Fast Snapshot Restore. So it works on a credit-based system. If you take enable a snapshot with FSR state, it will go from enabling to optimizing state, and it takes approximately 60 minutes for 1 terabyte of snapshot size to be fully enabled. And once the snapshot is fully enabled in FSR state, you can restore the volume and expect the performance instantaneously to the desired performance of your volume type. So there are two benefits of the key benefits. One is predictable performance once you launch your volume from an FSR enabled snapshot. That's predictable performance. Second one is you don't need to invest on your EC2 infrastructure, attaching the volume and reading the bytes off of through some command line utilities such that you load all the bytes from S3. So these are two distinct benefits for FSR enabled snapshots. And question I get most of the times is, so I have FSR enabled in availability zone 1, but my I have to restore a volume in a different availability zone, availability zone 2 or availability zone 3, AZ2 or AZ3. So this is, FSR is a zonal setting. if you have to restore based on your business requirements to another AZ, then you have to enable FSR state for that specific AZ for the snapshot. Then you can restore it with full performance. And most of the times customers ask, hey, how can I keep track of enabling FSR? I may not need FSR forever, but I don't want to be blindsided and pay additional costs. So this is where the next topic of Data Lifecycle Manager or DLM will help you how to clear the FSR state for some of the snapshot that you no longer need in that faster recovery setting. And second topic of the snapshot segment is the multi-volume crash consistent snapshot. So this, imagine an EC2 instance that you have with a few EBS data volumes, and some of the data volumes may be in a RAID group, right? So what you need to do is enable multi-volume snapshot by specifying an EC2 instance tag, and you can exclude the boot volume. And there may be additional data volumes. Say, for example, user data is in a RAID group, whereas system data is on its own data volume of EBS. So all of them will be taken a snapshot at that specific point in time, such that you want to restore your RAID group and EBS system data volume to another EC2 instance. You can restore it to that recovery point in time, and the RAID array will build in the background for you. And now we come to the last topic of today, the Data Lifecycle Manager. So snapshots is a powerful tool for protecting your data. And now what DLM adds to that is how to make it, or you can automate it using some policy-based settings with respect to tags based on EBS volumes or EC2 instances. So EC2 instances, you can tag it. So tagging policy and tagging regimen is very important, not only for your DLM and snapshotting, but also when you copy a volumes snapshot from one region to another region or one account to another account, that will have the lineage of, hey, which volume this snapshot belongs to. So tagging is very critical for you. And DLM helps you inherit the volume tags to the snapshots. And you can retain backups at variable retention policies. That's the key feature of DLM. In region 1, you can say I need only the 2 most recent snapshots, but for business continuity, I'll copy the snapshots to region 2. We will do that in the lab today. And then I will retain 5 snapshots and in my disaster recovery region, vice versa. And then you can have security-based IAM control policies to access your DLM policies so that you can restrict your access on how DLM policies can be managed. Most importantly, DLM is at no additional cost to you. Even though DLM makes API calls in the backend service, it's no cost to use. But let me repeat, on the snapshot copying from one region to another region, you incur the standard data transfer costs. What are some of the latest features that we introduced in DLM? So support for granular backup intervals, up to 1 hour granularity. And then this is all you can able to set through API CLI or from your management console. And this is also compatible with CloudFormation templates. And you can create retention policies based on not only on the snapshot count, but also on the snapshot age. And we introduced just a few weeks ago flexible scheduling per each policy. So we will see what it means in the lab. Snapshot retention is now possible based on number of days and weeks and months. And then at different region, you can have different set of retention policies to meet your business continuity and DR requirements. So this is a picture of what we will see in the lab of how to do a cross-region copy of your snapshots. And if you want the snapshots to be copied across multiple regions, for your business continuity, or say one region you may have a staging environment and one region you have a backup only region setting. You can follow along in the lab and create some policy rules such that you can see the action live. Now we are coming at the last segment of the workshop, which is a hands-on lab. This is about 10 to 15 minutes. What we will do is walk through the lab objectives now first. Let me go back to the previous screen. Some of you who have joined later, the lab instructions can be downloaded from this bit.ly link. Please make sure it's a PDF document. You can follow along the document and follow me while I demonstrate the Data Lifecycle Manager to you. Objectives. First, we will create an EBS volume, encrypted EBS volume with tags, and then create a test DLM policy. And after that, I will show you how DLM events are logged in CloudTrail Management Console. This data is very critical for you because you will see the success of each of these policy tasks of the DLM policy you just created. And cleanup is more important. So once you already are working on a test account, non-prod account, because you'll be tagging a volume, one or two, that up to you. So make sure that when you create a DLM policy, this does not interfere with your active production environments. So I highly recommend that you work this lab in a test account, please. I selected US West 1 and West 2 as my primary and disaster recovery regions. And this lab requires management console access. I'll give a moment for you to download the link. And then the chat function, if you need help, you can always ask in the chat function for the lab. And cleanup. Don't forget to clean up. The cleanup is also explained in the lab document on FSR state cleanup, DLM policy cleanup, and EBS volumes that you have created for testing in the lab today that you have to clean up. All right, let's jump back to the lab document here. I hope you're all able to see my screen. This is the workshop document. Let me maximize this. So here, let's go through step by step. So I already reviewed the overview of the lab. Prerequisites. What are the prerequisites here? So access to your non-prod account, launch the AWS Management Console. So let me launch the AWS Management Console. I'm typing in username and password for my AWS Management Console. Northern California is my region of choice, US West 1. And I'll also create a policy to copy to US West 2 and see in both regions. Let's go to task number 1, create an encrypted EBS volume with tags. So if you're already familiar with creating a volume, or if you already pre-created a volume, just follow along. So let me start by creating a test volume here, which is GP2 volume of size 10 gigabytes in US West 1A. Okay. Go to the EC2 dashboard and then go to the volumes tab here, and you'll see create volume. And we select a 10 GB GP2 volume in US West 1A. It can be any availability zone of your choice. And we are not creating it from a snapshot. And I was explaining before, I have enabled encryption by default for my settings here. So every volume is encrypted at the time of creation by the CMK, or customer master key. If you don't have a CMK, you can choose the default AWS/EBS. But for my side, I'll keep the customer master key. And you can choose your own setting. And then the tag is important here. So tag is, as I told you before, test DLM daily snapshot. So this tag is critical for us to create a policy based out of these tags. So in the document, I believe I have also given you the test DLM snapshot. Yes, test DLM daily snapshot, and the value is enabled here. So I have to create enabled as the value and create volume. So volume instantly creates and you get to see the volume ID. So you go back to your volume. This is your volume. For now, we did not name the volume, but now that we already have the volume ID, so let me throw in the name of this volume as well. That's the hygiene volume naming scheme, because name tag, if you have different cost allocation tags, so and enable name as your active cost allocation tags, you can see the volume and its associated snapshots. So that's for a different lab and a demo at some other time. So let's go back to the document here. We have created a volume with the specific tag test DLM, and I missed the step of naming it, and I named the volume. That's okay. If you already named as test DLM volume, that's fine. Let's go to the snapshot lifecycle policy. What we are going to do is navigate to the lifecycle manager and elastic block store section, and we'll create a new snapshot lifecycle policy. And remember the tag we have just created for our volume. So go to the Lifecycle Manager on AWS EBS EC2 dashboard, and we'll create. I have already previously created some policies, but we will start from a new policy here for this specific activity. Let's go back to the instructions document 2. Make selections for the snapshot lifecycle policy as shown below, and what we are naming is test DLM policy. So it's test DLM policy. Here is the key here. So this is something, let us spend a minute or two. As I explained before, volume is for individual volumes with tags, but if you select an instance here, this will be applied to an EC2 instance with any of the following tags of your choice, and this is the key for your multi-volume snapshots, crash consistent snapshots. So if you select individual volume based on the policy, the initiation of the snapshot time may be skewed such that when you are recreating your RAID group, you may see challenges. But when you create instance based for a multi-volume snapshots of a single EC2 instance, that's the key here, single EC2 instance, then at the same instance, you will get snapshots for all the EBS volumes attached to that specific instance. You can exclude boot volume as well. But for this lab, we will go with the volume as explained in the document here. Let me zoom in a little bit. I hope you are still able to see my screen or the lab document, whichever is convenient to you. So, and then what we need to do is target with these tags. So the second one, what are we targeting here? We have created a test DLM policy snapshot. That's our target. And what is the value that we have created? Enable. So that's one tag we have. You can have multiple tags. You can have production environment, staging environment, enabled, false, true. All this tagging policy is something you have to follow as a regimen. What if you don't have tags enabled and now you're creating a new policy? So what I suggest and recommend is go back to a tag editor in your AWS console and select those EBS volumes or instances based on your requirement. And from the tag editor, you can bulk create tags for DLM policies. And after creating a DLM policy, let's walk through that. So after this lifecycle policy tags, this is say DLM manage. We are adding a name DLM tag called DLM managed and calling it true. Go back to the document here again, just keeping consistent with the document, it's lowercase true. And the next one is keep the default role. So you're not creating a new role, but if you have IAM policy restrictions in your organization, you can make sure that you choose a restricted role such that only those people who are able to can access the DLM policy for any modifications. And then if EBS default role is not present, one will be automatically created for you. So the next one is the policy schedule 1. Why do you see 1? I'll come to that in a little bit. So let's go back to our document and see what we have set the settings here. Schedule name, test DLM policy daily. Let's rename this. Test DLM policy daily. Frequency, keep it daily. Go back to the document. And every 24 hours for this lab, starting at 9 UTC. So here is something you need to understand. Once you set up a DLM policy starting at, the DLM snapshots may be created within that hour. It's not at that specific minute that you set. From that specific time you're enabling the policy, within the hour a snapshot is created. So for now it's let's do it in the UTC. If you're following the UTC time, it's about 16:15 in the next 3 minutes or so UTC. Retention type, let's go back to the document, count and 2. Keep the count and 2. So what does this mean? So let me go to the tooltip here and see what the tooltip talks about. It's the number of snapshots that you would like to keep. The oldest snapshot beyond this number will be targeted for deletion. So this is the advantage of a DLM policy for your snapshot management to reduce your costs. It takes care of it automatically based on the service selections you have just made. So copy tags from EBS Volume, let's do that, enable that, because we have already named it. So we need that name in our snapshot tags as well. And we can create additional tags. So let's go back to the document. We haven't created any additional tags. We'll skip that step. And let's go to the FSR section. So by default, it's not enabled for your snapshots that you're creating. So you have to check this box, enable for how many snapshots? So enable for 1 snapshot. So even though you are creating 2 snapshots by EBS DLM, only the most recent snapshot need to be FSR enabled, and all the previous snapshot, you don't want them FSR enabled. So that's the key difference here. FSR state versus the state is not enabled. And availability zone. So whether you check whichever availability zone you want to be restored. So let's go back to the document, and I selected US West 1A. I'll keep it the same settings here. And you can enable multiple availability zones as well. So why not? Let me check that as well. Both 2 availability zones. I'm enabling FSR state for this one most recent snapshot in AZ1 and AZ2 of this US West 1 region. And here we talked about for disaster recovery purposes. So again, coming back to the theme of this workshop, one is data migration, EBS APIs you have seen natively, and DLM for disaster recovery. So you enable cross-region copy here. You select enable cross-region copy. As it says, will incur charges. And where are we copying for this specific lab? I selected target region US West 1 and retaining 2 snapshots after creation, 2 days after creation. In the previous one, I selected count. Now I'm selecting a different retention period, policy, 2 days after creation, and encrypt this snapshot. That's the key. So you have to encrypt the snapshots, right? If you are not encrypting your EBS volumes and snapshots, ask yourselves why not? Because its encryption by default is available for your security purposes now. So I've pre-created a master key. That's the best practices, because you can share the snapshots across regions and across accounts, not through DLM, but if using APIs, you can share CMKs through CLIs as well. But for DLM lab purpose, I selected master key that I have created before, not the default here. But if you don't have a CMK or a customer master key, you can go with default. You can change whichever master key you want at the time of policy, and you can also modify it once the policy is created. So let's go back to my keys. This one, US, one of the keys. So what key did I select? Oh no, I did not change the region. So let me go back to US West, which is Oregon, right? US West 2. That's the key setting here, target region. So if you have kept this as US West 1, please change it to a different region, which is US West 2, as per the lab documentation. And in the master key, I'm selecting my US West 2 master key for the account. And you can add up to 3 more additional regions, but we will skip that. Copy tags from volume, keep it enabled. This is the flexible scheduling. So first policy schedule 1, what we have done is we have created a policy document master policy of schedule daily, every hour at this time. We are coming close to that 15. I don't want to miss it. So let me change it to 17 as I'm talking through. Okay, let's go to the next segment of schedule 2. I'm not creating additional schedule, but I'll show you what does it mean. You can create additional schedule with a different frequency and a different start snapshot time. So let's not do that as per the document. Let's review the policy summary. This talks about your policy summary and what is the frequency of the policy, whether it is FSR enabled or not, and what are the regions you're copying. So, and then at the end, you have to enable the policy. If you disable the policy, you cannot create snapshots and create policies. Now let's see if I have followed the document as written, it should not be erroring out. Cool. So I have this policy. I'll just copy it. I don't know why, but I just copied it. So we have policy ID. Oh, that's right. We have this test policy here. So what it will do is it's created time, and if you have modifications, it will talk about that. This is enabled, and the schedule is, it will start at this test schedule, 16:17 UTC, which is about minute and a half or so. Why I've selected the time is, even if you pass the 16-17 minute, you may not see a snapshot created. So it's okay. It's not working. So the first snapshot will be created within the hour window, 16:17 UTC to 17:17 UTC. You will see your first snapshot created. If you have created an instance-based snapshot for multi-volume snapshot, the same pattern happens within the hour, but at that point where snapshots are initiated, all the volumes attached to the EC2 instance will be created at that exact moment to keep them crash consistent in the RAID array. So let's go back to our Word document here, what we have done so far, created a snapshot policy, and then as I explained here, at this stage, the snapshot lifecycle policy is ready for execution within the hour from the schedule you define. All right, let's come back. Once your snapshot policy kicks in, how are you monitoring it? Snapshot, you can go to CloudWatch, create alarms, but I have created a specific CloudTrain console view for your lab. So in the next, if you're coming out of this lab in the next half an hour, and if you don't see the snapshot created, I encourage you to wait for some more time, and then after that you delete all the resources after you examine the successful execution of all the DLM policies. So for now, let me go back to my AWS console and refresh this, and I'll go to my CloudTrail console. Because I have recently visited, it's already there. So what does it say? I'm in Northern California region. I'm in the CloudTrail console dashboard. I'm in the event history section. So the document says go to the event history page and look up events and filter by this username filter. Let's do that. Go back to view your full event history and drop down to username, and I select my data lifecycle manager events only and keep it in the last 30 minutes. So the first one has not created yet. This is the one which I have done before coming to this workshop, so that I wanted to show you how these events are logged in the CloudTrail console. So what you see is I hope you are tracking my cursor here. Describe volumes every time the DLM policy is kicked in. The DLM APIs make sure in that specific region the policy is created, it will scrub the entire volumes that you have created and see how many volumes are with that specific tag, the test DLM policy enabled tag. And then it will pick up those set of volumes. Now that you have created the policy, and the question is, what if I create a volume after the fact, like tomorrow, day after tomorrow, a new volume, and have a tag to it? Yes, the next run of the DLM will pick it up and enable the same policy to those newly created volumes. And the question is, okay, I have hundreds of snapshots that I have not created before using DLM. Can I bring it in? As of today, the DLM only takes care of management of snapshots created by the DLM policy. Stay tuned for further updates for the next few months or so, or if you have any specific requirements, you can always talk to AJ, who is the product manager, and then he will take your requirements. So engage with your account team so that, hey, I have this specific requirement, how can I enable that? So we take your feedback and put it in our next release and prioritize it. So let's go back to, let me refresh this once and see if it's not done yet. So that's okay. So it might take within the hour. So I am greedy here and saying that 2 minutes it will kick in. It may not. So as per the document, it will be start creating snapshots within the next hour from that time, 9:17 UTC, 16:17 UTC. Okay, so we are coming up to the end of the lab here. We have about 10 more minutes. So if you're waiting for the snapshot to kick in after you want to see all the copying to other region, so let's see other region also. There's one quick US West 2 region. I want to show you how the snapshot copy CloudTrail logs. So here you see that copy snapshot. So that is the API that you will see in the CloudTrail log. And when you go back to your snapshot instances here on the EC2 dashboard, you will see what snapshots have been copied. I'm quickly browsing through that. So this is copied from US West 1 for this specific volume because you asked the volume tags to be inherited, and the policy name will be in this, and it is DLM managed. This was from last night's pre-execution, so that it was a different policy for me. For today's policy we created was test DLM policy, and you should see the tag here in this space. All right, let's go back to the conclusion of the lab here. I hope you got time. I rushed through the lab a little bit, but the document is self-explanatory. Please follow along the document at your own leisure. And if you have any questions, you can always reach out to us through your account team, or have our emails also in the last slide. We will talk about how you can get in touch with us. Let me go back to my PowerPoint presentation. So in the next 5 to 10 minutes, let's wrap up. So what we have seen today, it's been a long workshop. Thanks for your time and interest on a busy day based on your schedule, and some of you dialing in from Europe and India. It's already weekend. Thanks for your time. Key takeaways. Check out the latest Amazon EBS offerings with this link, and this is a dynamic link. Every time we launch a new service, you can refresh it and it will be available here within a couple of days after the launch of the new service. EBS Direct APIs, we have seen a demo. AJ has walked us through what are EBS Direct APIs and how you can leverage read and write APIs for your business requirements. And then we have seen Nitin's demo of moving data from on-premises block storage to AWS as an EBS volume snapshot without the need for pre-creating a volume or an EC2 instance. And in the lab segment, we have worked on Data Lifecycle Manager, or DLM, and we have covered what is FSR, Fast Snapshot Restore, and we have covered policy creation settings in DLM, and we also talked about how to automate the entire snapshot management. And coming back to the theme of the workshop, disaster recovery purposes, how to copy the snapshot from one region to another region, encrypted snapshots by customer master keys or default AWS keys to another region, and have a variable retention policy in your disaster recovery region, and delete the old snapshots that are no longer required for your recovery point objective to keep the costs down. So that's the key takeaways for you to walk out of today's workshop and presentations. I created this slide for resources. Take a screenshot now, but this will be available within a day or two on our AWS Tech Talk channel on YouTube. With this slide link, I will ask the tech team to upload the slide deck as well in a PDF format. So these resources, most importantly, the last bullet, EBS Customer Stories. This is where you see how tens of customers, I think there are about 40 plus customer stories that they are referenceable. And thank you again for all the referenceable customers. Your best practices influence hundreds of other and thousands of other customers. Coming back, so we have this week session. We had 3 sessions this week. Today is the EBS Snapshot session. And next week, as part of this virtual workshop series, you have Windows and FSX, S3 security, which is one of the most popular sessions, and cross-account management using AWS backup. So please do sign up for those if you have not attended, signed up yet, and go work on these workshops along with us. Please complete the session survey. You will get a link, as Eric explained before the start, and here are our email addresses. Feel free to reach out to us. I prefer if you engage your account team, account manager, but if you have an urgent question, feel free to email us at any time. Last but most importantly, in end of November, in a month time or so, you'll have AWS Reinvent, and I'm speaking again on one more session there. So I'm not telling you what I'm speaking on, but stay tuned for Reinvent session. And there are many storage sessions in EC2 as well as storage track. So please join us at the Reinvent virtual workshop. This is a free virtual workshop, virtual Reinvent session. I'll come back to the session survey and any questions if we have in the chat room. AJ or Nitin, are there any open questions that we need to take live?
There's one question that I'll read out. The question is, the DLM scheduled job seems to not start on time according to the UTC time. And so the question is, do we look at the UTC time?
The selection mechanism is UTC in the DLM policies. What you can do is, as I said, it will take about 1 hour from the scheduled time in the UTC. It is not the regional time of the region.
Thank you, Sudhakar. No other questions in the chat.
Cool. Basir, are you still around from London? Can you unmute?
Yes, I'm here.
All right.
Yeah.
You have any comments about Basir is our fellow solution architect from London. Anything you want to add, Basir, for today's workshop session?
Yeah, all looks good. So only things I just wanted to point here is like the newly launched features on the FSR side. Like earlier we could not do kind of enable FSR if the snapshots is shared. Like now you can enable FSR on a shared snapshots. Like and this means like you can eliminates the need for the copying snapshots from the other account to your account and enable FSRs. So this basically saves a lot of cost and a workflow. So that's what I want to kind of point it out here.
Thank you very much, Basir. I missed that point. Thank you for reminding that. Shared FSR for shared snapshots we just launched about 4 weeks ago. Thank you so much. Any other questions in the chat room that we can take live? One of us?
No, Sudhakar.
Thank you. And again, thanks everyone for joining. Please complete the session survey and looking forward to working with you on any of these topics. If you need a deep dive, please reach out to us here on the email or your account team, and we can schedule deep dives, and stay tuned for reInvent updates.